Hi, everyone. Can you guys comment that you can hear me okay? Hi, everybody. Okay, good. Can hear you. Yes, we can hear you. Great, fantastic. Okay, so this is my first live online review session, and I'm super pumped. I want to thank Fiveable and Amanda and everybody for helping me kind of find my way here. I'm really happy to be doing this, especially because we now have 4 days, right? Well, less than 4 days. So I'm super pumped. All right, so I am going to go ahead and share my screen so we can see the slides, and we're going to, hi Hannah, shout out to some of my students that are popping on here too. Like I said, I'm super excited. Okay, so I'm gonna go ahead and share, get that going. Let's see. My plan being let's see here. My plan being to, excuse me as I kind of blow my nose, get through some slides. Of course, we're going to talk about research, right? But also, hang on one second, get your questions, right? I know that is super important. I have seen your YouTube videos. Awesome. I'm so glad you've seen the videos. And I'm so glad they've been helpful. If you haven't seen those, I'll show you kind of my channel so that you can see those. All right, so I want to make myself, sorry, okay, it's fine. I don't have to be able to do that. Okay. Here we go. So here is what we're going to talk about, research methods and how it can make or break you. And I want to use a little Yerkes-Dodson law there. Ooh, there's some non-research for you because here's the thing. I want you to be kind of amped up about it, but also know that you've got this. And so it really can make or break you, and I'll talk about why. So again, I'm Mandy Rice. Welcome. I put my website there, teachonamission.com, and I am that way on lots of different social platforms, Twitter being slightly different. And then my newer YouTube channel is Mandy Rice. My old one is still up. It won't be there forever. So if you want to keep following along, even though the AP exam is this week, make sure you subscribe to my new channel. And I'm going to click back here just to make sure that I see any comments and stuff. Okay. All right, here we go. So in this session, we will discuss how correlations and experiments are different. And you probably know what that difference is, but how that leads us to the more complicated stuff. And hopefully seeing that tie will make it easier for you. So those basic components of experiment. And again, the big conceptual understandings in statistics. So some key terms, independent, dependent variable in those experimental groups, the normal curve, and we'll really talk about what that could look like on the test, statistical significance and null hypothesis. And I'm betting that those last two questions or those last two terms there are what kind of freak you out. Don't worry. We're going to talk about it. Okay. So first we're going to talk about correlation versus experiments. So you know this already. You know that correlation does not mean causation. You know this, but we do need to clarify why then experiments do allow researchers to determine causation. We've seen it on test after test where a question simply wants you to be able to identify that an experiment is the only research method where an experimenter can show cause. Okay. It's the only research method that can show cause is an experiment. So correlations, let's kind of break it down here in that there are two variables that have a relationship or somehow impact one another. Again, just a quick overview, right? But I want to talk about the correlation coefficient really as a reminder in that I want you to take the two components of the coefficient separately. And that only look at the sign, negative or positive, and then only look at the number. So I'm going quickly here because I know this is kind of review, so we can talk more about the confusing stuff later. So the negative means that it then has a negative slope, right? And that's how it gets us to scatter plots, whereas the positive one has a positive slope. And then the 1. Can anybody tell me what the 1 means? right? What's the number? So it doesn't necessarily mean 1, and it very rarely will be 1. So just comment really quickly. What does the 1? What does the number of the correlation mean? Good. I see 1, correct. Anybody else? Good. It's the strength. I concur. Good job. It's the strength, right? So the number of the correlation coefficient is the strength, meaning the line of best fit. How, I'm trying to think of the word, how visible, how noticeable is the line of best fit, right? If there's lots of scatter on your scatter plot, that's not a lot of strength, right? It's going to be closer to 0, whether that's like negative 0.01 or positive 0.01, right? Then the more scatter, the less strength, right? The less scatter, the stronger that relationship is between the X and Y axis, the two variables. Okay, now experiments are more controlled. Okay, and that is due to assigning degrees of the independent variable to the groups of the experiment. Now, if you're taking notes, I highly encourage you to do that. I want you to do a little sidebar here really fast. So somewhere close to where you're jotting down about experiments, but we need to talk about this term here, degrees of the independent variable. We've seen this on the test as well. And I'll be honest with you, when my students saw it, they reported to me when they were allowed to, days after the test, that they were like, what are they talking about? I don't know what they're talking about. Degrees of the independent variable. Well, here's what I say to my students. I say, okay, you have the experimental group, you have the control group. Which group is assigned the independent variable? It's a trick question. So I'm going to hop back and see, like, let me ask you this. Go ahead and comment. Which group, experimental or control, is assigned the independent variable? I thought you would say this. Experimental group. What if I told you that you're kind of sort of, oh, hi, Kaylee. What if I told you that you're kind of sort of wrong? It's both. Yes. Oh, somebody said both. No. Yes, it is both. It's both. And here's why. Because it's the degrees of the independent variable. Right? So if I'm doing an experiment on the impact of caffeine on happiness, okay, so I'm going to ask for comments again. If I'm doing an experiment of the effects of caffeine on happiness, what's my independent variable? The effects of, and go ahead and comment for me, what's the independent variable? Good. It's caffeine, right? Okay, but then here's another question for you, and I want you to comment. What do I give to my control group? What do I give to my control group? Good. None, nothing, no caffeine. A placebo would be like super bonus points if you were to comment that. But here's the thing, that's still part of the independent variable. That's what they were talking about in I think it was an FRQ a few years back where they asked about the degrees of the independent variable. You have to include, when you're describing the independent variable, the degrees of it, meaning what you would give to your experimental group and what you would give to your control group. So in my example experiment, that would be caffeine to my experimental group and decaf, which would be like, right, a placebo or nothing at all, right? Like I have to include all of that in there. Okay, so that was our sidebar. Let's get back to what we were talking about. Now, we kind of just went over independent, dependent variable. The independent variable being what's controlled by the researcher, right? And more importantly, what you should write down is the IV is what is assigned to the control group or the experimental group, right? The degrees of the independent variable. Then the dependent variable is what you measure. So if it's something like, here's another sidebar review for you. If it's something like happiness, how it makes you feel, your mood, your preferences, your beliefs. So I'm going to go back and look. I want you to comment. If I am measuring something like attitude, beliefs, preferences in an experiment, how would I measure that? What tool, what research method, you could say, would I use to measure attitudes, beliefs, or preferences? Oh, I see it. Good. A survey. Yes. The only way to assess anyone's attitudes, beliefs, anything like that is with a survey. Good. And I see some of you saying operational definition. I saw that somewhere up a little bit. That would then be your operational definition. Okay, your operational definition, which makes your dependent variable manageable and more importantly, measurable, would be I'm going to measure the attitudes, I don't know, the happiness of both of my groups with a survey. I'm going to do that before they take their the independent variable, their degrees of the independent variable, and then again after a week of them drinking either decaf or caffeinated drinks. Okay, so the operational definition is that I would be using a survey to assess their attitudes. Okay. Confounding variables. Okay, so let's run with this example experiment with caffeine. Can somebody please put in the comments what a potential confounding variable would be? A potential confounding variable. Okay, I see mood, not getting enough sleep. Yep, sleep, had a bad day. The weather, ooh, good one. The amount of caffeine they've already had. Can anybody use a states of consciousness? For us, that's Unit 5 term for me there. Caffeine addiction, I see. Tolerance, there it is. Winner to Ophelia. Yes, very good. It's right. If they've built up some tolerance, all of these are really, really good. Regularly drink caffeine, meaning they've built up that tolerance. Remember, you want to be using those types of terms if you were to write about it in an FRQ. Good. Oh, yeah. Size, I guess, is a good one, too. Good. Okay. So confounding variables being anything on the outside that could impact their research. And then causation. We've talked about this, but we need to talk about how in an experiment is the only one that they can determine cause. And the reason why is the next thing we're going to talk about. Random sampling versus random assignment. Can anybody tell me, okay, I'm going to go back for a second. We're talking about causation. So we'll say that these two terms, random sample versus random assignment, are like your options. So here's my next question. Why is it, which one of these two terms here, random sample versus assignment, explains why experiments can determine causation? So which term, sample or assignment, allows the experiment to determine causation? This is a hard one. Ooh, yes, good. Good. Yes, it's assignment. It's assignment. Yes. Okay. So let's talk about a little overview of these two terms. Okay. So random sample is kind of like step one when you're going to do really any type of research, including in experiments, but even in correlational studies, even in surveys, questionnaires, blah, blah, blah. You always randomly sample. Okay. So that's kind of like step one. Then in an experiment, the experimenter, the researcher, randomly assigns their sample, their participants, to either the experimental or the control group. Okay, and here's the big understanding I want you to take away. Random sample allows for generalizability. Okay, random sample allows you to generalize, and this could be something you're writing down, allows you to generalize to the population. Okay, your random sample, if it is truly random and therefore representative of the population, the researcher is able to generalize and say, this was true, blank was true, caffeine had this much impact on happiness in our sample. And because of our random sample being very representative, we're able to generalize that to the entire population. Random assignment is then what controls for pre-existing differences between the two groups of control and experimental group. So I'll say that one more time. Random assignment is then what allows the researcher to control for pre-existing differences between the two groups, like caffeine tolerance, how much sleep they got, what the weather was like, if they had a good or a bad day that day. Right? If they randomly assign their groups, they're doing a good job of controlling and making sure that it's caffeine or no caffeine that has an impact on their dependent variable, and that's it. That's the only thing that's impacting the dependent variable. And that's why a researcher can determine cause with an experiment, because they've covered all their other bases. They've made sure through the structures of their experiment and the research method itself that caffeine, or the independent variable, is the only one causing the difference between their groups. Okay, does anybody have any questions so far? And then I need to make sure that I'm seeing your questions. Ooh, I see questions. Okay. What's the difference between control? Okay, so I see what's the difference between, okay, let's see. I want to get one that's voted up pretty high. Can you go over operational definition and depth? It confused me so much. Okay, so let's talk about, we're going to start answering this one. Can you go over the operational definition in depth? It confused me so much. Yes. Okay, I want you to just take a deep breath and get rid of the confusion, because it really is so darn simple. My students and I, we are wearing a shirt for AP Psych that says something along the lines of psychology is a bunch of terms that you already know, but putting confusing words to it to like confuse you even more. And this is exactly what it is. Okay, an operational definition, you need to know what it is, like what its purpose is, and then what it allows in the world of psychological research. Okay, so an operational definition makes the dependent variable both manageable and measurable. Okay, so let's say that you're doing like some kind of natural observation in like the cafeteria of your school, and you want to see if people sitting closer to the window, like closer to natural light, are happier than the people sitting not as close to natural light. Okay. Oh, it paused for me. Okay. Questions page. Okay. Okay, we don't have an issue, I don't think. Can anybody still hear me? It says it paused for me. Can everybody still hear me? Can you comment and let me know? Oh, good. Okay, good. Yes, 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 yes. Beautiful. Okay, so let me scroll down. Here we go. What was I saying? Oh, so here's the thing. How would you measure if the light made people happy or not? Well, some people said, oh, good. Somebody just said, make sure to refresh. Thanks, Tam. Said to refresh your page. Good. Let's say that, somebody that is going to be observing in the cafeteria, because it's not the same person every single day, right? And researchers have undergraduate or graduate students helping them, and they're sitting in the cafeteria, and this is like at the college level, right? And they're saying, oh, that person looks really happy. I'm going to mark them as, yes, they're happy because they're sitting by the window. Well, if the researcher doesn't say, this is how you're measuring it, then all of their graduate students are going to measure it differently, and it's totally botched, right? It's totally awful. So that's kind of the purpose. The purpose is to say, we are going to measure happiness by giving them a survey, right? Every day in the cafeteria, we're going to give them a survey. We are going to mark on their paper where they are sitting, and then try to determine the correlation between their level of happiness and where they are sitting in the room. Okay. So that's kind of the purpose and what operational definition is. It makes your dependent variable manageable and measurable. It determines how everyone is supposed to measure that dependent variable. Now, why you have to do that, which is kind of in the example I just gave, is so that it can be replicated. Okay, those are the two big understandings for operational definition, so that the research can be replicated, so that the graduate students that are sitting in the cafeteria handing out these surveys and stuff, well, making sure that they hand out the surveys, right? And they're not just saying, oh, I saw that person smile, they must be happy. Okay, all right, so I think I'm done on that one. I'm going to say done answering with that one. Okay, good. Interview versus a survey is not very different, although be careful with the word. Oh, no, here, let me start answering this one. Interview versus a survey, not very different, but oftentimes with interview, you're talking case study there. Okay, case study is just individuals or very few people, whereas a survey, you're talking thousands of people, right? Because it's easy to administer. So I hope that answered that question. Okay, let's see. I should probably sensation. Okay, important people. I'm going to answer that other one later. Let's see. What is a stratified sample? Okay, so I'm going to start answering this one because it's pretty applicable here when we talk about sampling. So what is stratified sampling? Okay, so stratified sampling is kind of like a super cautious way to make doubly sure that your random sample is representative of the population. So let's say that you're going to do an experiment at your school, and let's say that it's 9th to 12th grade, like most traditional high schools are. And let's just say that you want to know the impact of caffeine on happiness. Okay, so you're going to give everybody a survey at the end. Okay, but first you have to randomly sample them. Well, in order to randomly sample them, and here's the definition that you'll probably want to make sure you get down, to make sure that everyone in the population has an equal chance of being chosen. That's random sampling. Some researchers may go another step farther and make it stratified. And that's where instead of putting all 9th and 12th graders into one bowl or into one hat where they draw names, they will have 4 bowls or 4 hats, one for 9th, one for 10th, one for 11th, one for 12th. And they pull, let's say, 20 names from each hat to make sure that they have a very representative sample of each of the grade levels. And that's it. Pretty simple. I hope that was helpful. So I'm going to click done answering on that one. Okay. And then I'm going to get back to where we were. Okay. So this kind of is our segue. Experimenters want to make sure that the only difference between their groups that has a significant impact on the dependent variable is the what? So I'm going to go back to see in the comments. Experimenters want to make sure that the only difference between their groups, their experimental and control group, that had a significant impact on the dependent variable is what? Yes, this is like the most simple question ever. It's the IV or the independent variable. Very good. Okay, now here's the thing. An experimenter, like hang on a second here, an experimenter can't just say that their independent variable is in fact what caused their 2 groups to be different, and therefore the dependent variable to show or to prove that difference. They can't just say, yep, I'm brilliant, I'm amazing, I crossed my T's and dotted my I's, so it's for sure it. There's something else. They have to prove it, right? They have to prove it. Now, before I show you what we're going to talk about, can anybody tell me how they prove it? What's the vocab term where they prove it? They prove that, not replication. Replication is important for proving, I guess that's helpful, right? It's statistical significance. Good. Christopher Tubby said significance question mark. Not a lot of confidence there, but you're totally right. And then Adam Kelch said statistical significance. Nice job, Maddie, too. Very good. Okay, so that's where we're going next. We are talking about statistical significance and how you can be afraid no longer, right? No worries. We've got you here. I'm going to go back a little bit. Experimenters want to make sure that the only difference between their groups that has a significant impact is the independent variable. And they prove that with statistical significance. Now, major understandings for this term that you must have for the test is not how to calculate it, right? You could probably, especially if you're in statistics, you probably know how. You know way more than I do, right? You do not know how to calculate it. You just don't. Instead, you have to know its basic definition. The difference between the 2 groups is not due to chance, right? And that the experiment has to be able to say that, yes, it was my independent variable, right? Otherwise, why would they publish their work, right? It's worth nothing because it says nothing. Okay. Now, what difference? What difference can't be due to chance? Well, that's the difference between the 2 groups. So when they're measuring their dependent variable, they've got to make sure that the difference between their experimental group and their control group, right, on that survey on happiness is in fact due to the caffeine and not anything else. Now, the way that this is shown in math terms is with p-value. And the p-value has to be less than or equal to 0.05 or 5%. Now, what this means, and it's this last bullet point here, meaning that 5% or less of the difference between the groups is due to chance. If that's the case, then it is statistically significant and they have proven themselves, right? The experimenter, the researcher has in fact proven the value in their work. Okay. All right. Any questions before I move on? I'm just going to look at the questions, make sure that there's nothing for statistical research or statistical significance. Let's see. I feel like I answered what's the difference between the control group and the experimental group. I'm going to answer that really fast though. What's the difference between control group and experimental group? Okay. What I tell my students is that the experimental group is the one that gets the quote special treatment, right? Because they both get a degree of the independent variable, but the experimental group gets the special treatment. Okay, so they're the ones who get the caffeine and the control group gets the placebo. Or in a like research study on artificial sweeteners or ibuprofen, right? The experimental group always gets the thing. They get the artificial sweetener or the ibuprofen or the caffeine. Okay. All right. Let's see. Okay, so I'm going to answer this really fast. Example of statistical significance. I'm still lost. Okay, I can't necessarily give you an example other than to understand that p-value is what shows that a research experiment is not due to chance, that it is due to the independent variable. So in our example experiment, let's say that I'm the researcher and I want to know how caffeine impacts happiness. In all the math, that is way totally above my head and I have no idea how to do it. And neither do you need to know for this exam. You just need to be able to conceptually understand that with all the math that people can do, I need to answer that too. I'm going to come back to that, Alana. I'm going to come back to your question. Is it greater than 5%? Then it is. Okay. If it's greater than 5%, it's not statistically significant. Okay. It has to be. Yes. Good. Thank you, Kia. It has to be less than 5% in order to be statistically significant. So with our example one, if my research is statistically significant as proven by a bunch of math, the p-value will be equal to or less than 5%, meaning that it was the independent variable, caffeine, that caused a difference in the happiness of my two groups. I'm going to say that again so you can write it down. So in our research, if it's statistically significant, the p-value will be less than or equal to 5%, meaning that the 95 or more percent, whatever's left over, is in fact due to the independent variable. And that the difference in the happiness levels of my experimental control group is due to my independent variable. Okay, I'm going to finish that one. Flaws. Is p-value the only factor that affects statistical significance? Well, it doesn't affect it because it is it. P-value is statistical significance. So answering Max's question, p-value is statistical significance. So it doesn't affect it, if that makes sense. I guess you could say the only thing that would make a research experiment not statistically significant would be that there's confounding variables. Okay. All right, let me go back here. Okay, the next thing we're going to talk about is normal distribution. And I'm going to try to get through this stuff in the next 15 minutes so that I have lots of time for any other questions that you have. All right, so normal distribution of scores. And those scores could be any scores, any data that they're going to give you on the test, right? Any list of numbers. And I want you to write this down. It's a normal distribution of scores or numbers of data and how many times they occur. Okay, so really, technically speaking, it's simply a frequency distribution. Okay, you've done that before. You have totally, in one of your math classes, you've done like the t-chart, right? And you've had all your plots of data on the left, and on the right, you determined how many times each of them showed up. And it would look like something like this in a bar graph. Now, if I were to draw the curve on this, you would see the curve, right? Because that's exactly what the curve is. The curve just shows us how frequently each score on this bottom line here, the x-axis, right? Pretty sure, how many times it shows up. Okay, that's all a normal curve is. So here's my recommendation with the normal curve and the major understandings you need to do. This is what I tell my students. You need to memorize half of the curve, right? Because, and here's why I tell you to memorize half the curve. If you were to memorize the bigger percentages, like the 68.2 and the like 90, I already forget them because I've forgotten them, the 95 point something and then the 99, right? Those three bigger ones. The math gets really tricky in dividing it by 2 and then adding and blah, blah, blah. So I'm telling you, and your teachers may hate me for this, but it works for my students, to memorize 4 numbers, half the curve. And that altogether, 1/2 of the normal curve from the mean, median, mode line at 0 standard deviations and up or down is 50%. Okay, 50% of scores fall above and below the line. And then within 1 standard deviation is 34%, 34.1, and then 13.6 and 2.1. Okay. Now, let me tell you why this would be helpful for you. And I'm going to give you a typical test question. So this looks really familiar for my students who are on here. Let's say that Mrs. Rice's awesome AP Psych students took their exam and averaged 85% and had a standard deviation of 5 points. I want you to answer this question in the comments for me, but here's the thing. Don't look at the comments until you've answered it yourself. Don't just wait for someone else to answer it for you. How many students scored between 90 and 100%? Ooh. How many students scored between a 90% and a 100%? Ooh, that's hard. Let me get back here. Is there a possibility we won't get a question like this? Of course, there's always a possibility you won't get a question like any of them. Ooh, okay. I don't know how to solve this. Okay, we're going to talk about that. All right, I'm seeing lots of 15.7s. Neither do I. Okay, we are going to go back. I'm not going to tell you the right answer yet because I want you to figure it out on your own. And most of the answers I'm seeing aren't great. Okay, here's what we're going to do. I wish I could write on the screen, but that's okay. Here's what we're going to do. So at the mean, median, mode line is 0 standard deviations, right? So each one of these jumps here, so from 0 to 1, or this way, 0 to -1, is 1 standard deviation. Okay. And in the question, it has told you that 1 standard deviation is 5 points. Okay. So when I see this question, it tells me that I've averaged 85%, or the scores, the average is 85%. So I'm going to take that 85 and I'm going to put it down here in the 0 mark. You know what? We can go ahead and do that right now. Okay. I'm going to totally like do this here. So, and we're going to say 85%, right? 85% goes on this mean, median, and mode line because that's my mean, right? This is my mean right here. Now, if I have a standard deviation of 5 points, that means that each one of these jumps equals 5 points. So I just add 5 for each jump. Okay, so on this line, it will be plus 5, right? And then on this line, it will be 100%. So now let me ask you the question again. How many students scored between a 90% and a 100%? Oh, sorry, 95. You're right. I did my math wrong. No, did I do my math wrong? I did. I totally did my math wrong. You're right. My bad. Let me go back. I forgot a jump. That totally makes more sense. Choo-choo. My bad. So that does make the answers that you guys gave me totally right. Oh, I totally brain farted on you all. Shame on me. I was trying to give you just one jump there so you didn't have to do any math, but look at, I just totally messed it up. But that's okay, because that means most of you are right. Woo! Okay, here we go. So let's see. Let me get back here and present it so it's nice and big for you all. Good. It is 15, or yeah, what'd you say? 15.7, right? Okay, good. Thank you for laughing at me. Woohoo. Okay, good. All right, so each jump, I'm going to say it again, each jump here, one number increased, is worth, you could say worth, or equal to 5 points. So this is one standard deviation, which means that it's worth the 5 points, because in our question here, it says the standard deviation is 5 points. So we jump 5 each time. So it would be 13.6 plus the 2.1 would be how many students scored between 90% and 100%. Now, they could also totally throw you for a loop. Not that, I shouldn't say it that way, because they won't, because you're here and you're going to learn and it's not going to stress you out and it's going to be great. But they could give you all this information and then say how many students on a normal distribution of scores scored between 1 and 3 standard deviations above the mean. You really don't need any of this information then about the average and the standard deviation, because it's the same, right? So what I tell my students is that these 4 numbers that I need you to memorize, those never change. It's the data that you then put on top of it, which is the scores, right? The frequency of the scores in the test question that you then plug in to the normal curve. Okay, questions. Will they give these numbers on the exam? They could. Well, they're going to give you what you need to solve it. Okay, they're going to give you what you need to solve it. So if they're asking you how many students score between 90% and 100%, they're going to give you the standard deviation. They have to, because you wouldn't be able to solve it in any other way. But like I said, they could, give you all this information. They could say the average is 85%. The standard deviation was 5 points. And then they say how many students scored between 1 and 3 standard deviations above the mean. Then you didn't even need that information, because all you have to do is memorize and remember those percentages. I love seeing that we all had a light bulb. Oh, OMG. Okay, I get it now. Good. Awesome. Oops. Oh. Okay, there we go. This makes so much more sense now. Okay, good. Yay, I'm so glad. Okay, so what about the percentages? Well, let me clarify one more time here. So these blue percentages are what I want you to memorize, okay? These ones that we added at the end here, or down on the bottom in black, those are what we worked out given the information in the test question, okay? So don't worry about what's going to be in the test question and what numbers are going to be there. Just understand these blue percentages, memorize them, and know that one jump from 0 to 1, from 1 to 2, 2 to 3 is one standard deviation, right? So this is one jump. This is another jump. This is another jump. Each being equal to whatever they give you in that test question. And in this case, it's 5 points. Okay? Made so much sense. Will we have to use the formula for standard deviation? No. Ugh, formula for standard deviation? Ew, that gives me like the heebie-jeebies. I hope not, because I don't even know what it is. What even is, right? What even is the formula for standard deviation? I don't know. There's like that, what's that thing? The derivative and all, well, I don't know. The square root. That's what it is. I don't know. You don't need to know it though, right? You do not need to know it. You will not have to use the formula. Nope. Good. Okay, good. All right, so let's see. Here we go. All right, now I understand that this image, it's totally a screenshot that I took, is kind of blurry, but I think you can still read it, hopefully. Okay, so this question back here is what a multiple choice question would be, because what they'll do then is give you A through E options, hopefully one of them being 15.7, and hopefully another one of them not being 15.6, because That's just an example of why you have to read all your options, right? Okay, but this is what it could look like in an FRQ. So what can we learn from a recent FRQ on research? First of all, before I get to what I have written here on the screen, this was part C of A, B, and C, right? So this was only, research was only a third of this one FRQ, okay? So don't freak out is kind of what I'm trying to tell you. However, and I still don't want you to freak out because you're going to have this in the bag more than you know it. Starting not this Thursday, but next year, College Board has announced that every year, one of the 2 FRQ questions will be research-based. Now, I don't know about you, but that makes me think that this year might be a practice round, and they might even give an entire FRQ that is research-based. And they've done that in the past. Excuse me. They've totally done that in the past. Water break. So be prepared for it is what I'm saying, but also don't freak out, right? Don't freak out because all you got to do is make sure you don't read too fast. Because to be honest with you, I read this one too fast and I'm like, oh my gosh, this is so hard. And then I slowed down and realized this is so stinking easy. This is a walk in the park. This is great. But then also don't freak out as in take it step by step. Okay. All right, so we have this normal distribution of scores, right? We look at, here's the scores, here's the frequency, meaning how many times they occurred. I see that it's about Mr. Smith's class. If it helps you, say your teacher's name, right? Like whatever helps you, just don't then write that in the FRQ. Make sure you say Smith. But the mean is 70%, and we know that this middle line is the mean, okay? That's why it says mean equals 70 above the line. Okay, so the statewide results of a standardized math test had a normal distribution and a mean of 70. That's the first very important piece of information. Mr. Smith's students took the same test, and the graph above depicts their results. Okay, so we have like one piece of data, which is the statewide results, and their average is 70. And then this graph is of Mr. Smith's class performance on the same test. So here's what you would have to answer. What does the mean score of Mr. Smith's class suggest about how well his students are performing relative to the state scores? I'm really hoping that for some of you, you're like laughing at how easy this is. But I want you to go ahead and comment and put for me, like in as few words as possible, what you would say there, or just what you would answer to me. Maybe not what you would write in an FRQ, but what does the mean score of Mr. Smith's class, as shown in this graph, suggest about how well his students are performing relative to the state score? Ooh, somebody said bimodal. Would I make you feel better by saying you don't even have to go with bimodal? Totally don't need to say that. I don't know about you, but that's not something we cover in psychology. I don't know what bimodal is either. Something with 2. It's skewed. Ooh, Kaylee, we need to talk about that. It's not skewed. Well, ish, right? It's not a normal distribution. So I guess technically it's skewed. They're the exact same average students. I'm confused too. Okay, that's fine if you're confused. Ooh, good job to Kelly Bolt. They are performing just as well based on the average. The mean would be the same, right? Standard deviation being a little off, and it is skewed because it's not a normal distribution, right? They are performing the same. Good. We know this because of the mean. In that first bullet point there, what does the mean score? That's all they're asking about. They're not even asking about the normal distribution. They're simply asking about, and thank you to them for underlining it, the mean. So according to the mean, they're doing just as well. Now, sidebar for you. This is a perfect example that shows us which of the 3 measures of central tendencies is most impacted by outlying data, right? That's also been a question on multiple choice. It's something that College Board totally wants you to understand. So we have 3 measures of central tendency in the whole statistics world, right? We got mean, median, mode, right? Mean, average, median, middle, mode, most. Which one of the 3 is most impacted by outliers, meaning kids who do really well on a test and kids who do really poorly on a test? The answer is mean. And that's what this graph shows us. Because their average, Mr. Smith's class mean or average, is the same as the state's, but the data does not look the same, right? So what this means is it's most impacted by outlying data and therefore is less of a holistic picture of the data. Okay, the mean is less of a holistic picture of the data. Okay, all right, so that first bullet point we've pretty much got, and I'm like totally taking up all my time here, that they're doing pretty much the same as the state, given the mean score being the same as the statewide results. Now, the second bullet point, what does the underlined, thank you very much, test makers, distribution of scores in Mr. Smith's class suggest about how well his students are performing relative to the state scores? Now, this is another example. This is another example of how I don't want you to think too much. I don't want you to think too much here. But go ahead and put in the comments what you would say. So again, the question, what does the distribution of scores in Mr. Smith's class suggest about how well his students are performing relative to or compared to the state scores? Worse, same. No, they're doing the same. They're performing differently because the state is a normal. Good job, Maddie. Oh, let's see. Logan, you're kind of off on that one. Not really. Is that not the same question? Don't feel dumb, Crystal. Don't feel dumb. It is not the same question, and here's why. It is not the same question because of the underlined part, mean score versus distribution of scores. Let's look back to the little prompt that was given to us. It says the statewide results of a standardized math test had a normal distribution. Now, you know that a normal distribution is a bell curve. It is a perfect bell curve. Is Mr. Smith's class performance a perfect bell curve? No, it is not. So it is not the same. Bullet point 1 with mean scores. Yep, it was the same because all we were looking at was the mean. But what does the distribution of scores say? It is not the same. Okay, it says that more of his students scored above and below the mean. You could even say that an equal number of students scored above and below the mean, hence why the mean is still in the middle. Does that make sense? Yes, distribution is the shape, right? Distribution of scores, meaning how frequently those scores appeared in the data. Mean is the same, but the scores are over and under the mean. Yes. Good. Distribution is just how spread out the data is and how frequently scores appear in data. Yes. Very good. Yes. Good. So we're not looking for better or worse, right? You can't quantify better or worse because technically, according to the mean, they're doing the same, right? So yes, Mr. Smith's class is different, but how? Okay, so what would we write though? Very good. Here's what you would write. Smith's class is way more, polarized. Good word. Good word. Okay, so here's what you would write. Okay, so let me see. Relative to the state scores, Mr. Smith's class, as shown by, you could say, as shown by the underlying distribution of scores, a lot of his students scored above the mean and below the mean. And you could say something about, therefore, it's not a normal distribution like the statewide scores. Does that make sense? Yes. The student who asked me, how do I write that? Who was that? Do you understand? What will we write? Sarah. Sarah, do you understand? Let's see. Yes. Okay, good. I think I'm hearing mostly yeses and that we're good. Beautiful. Okay. So again, this was an FRQ. Another FRQ, I forget what year it was. I want to say like 2013. It totally it gave you like 2 data points, and students like totally overthought it. Don't overthink the numbers. If you conceptually are understanding what we've talked about in this review session, you are going to be fine if it shows up on the FRQ. Okay. All right. The last thing we want to talk about is the null hypothesis. Oh, and I need to go quickly. I can stay past 7, so it's a little bit. But let's talk about the null hypothesis. Again, you just need to know and understand it conceptually. You just have to conceptually understand what is the null. Okay, so I give you a definition here. It's a general statement or default. I like that word. It's a default position, because this is, researchers don't want the null to be right. They don't want it to be right, but they have to consider it, and we'll talk about why. So a general statement or default position that there is no relationship, not that there's the opposite. And I would write that down if I were you. The null says there is no relationship, not the opposite relationship. Okay, between 2 measured phenomena, or between 2 variables, or no association among groups who are given a variable, that kind of thing. Okay, so researchers must assume there is the possibility that there is no relationship, no cause and effect between their independent and dependent variable. I have to say that, caffeine could have no cause on happiness, and I have to do all of the math and that kind of stuff that you don't need to know about to make sure that my null is not true. Okay, but let's talk about why. Why would it be important to consider no relationship? Let me ask you this. Let's say that a doctor, a medical doctor, not a psychologist, nothing in psychology, just a medical doctor, a surgeon, the patient comes to them and has all the symptoms of appendicitis, right? Has all the symptoms of an appendix that is about to explode or has exploded. Okay, this doctor's hypothesis is that appendix needs to come out. That appendix is the cause of all of these symptoms, and it needs to come out. Okay, what if they're wrong, right? A medical doctor has got to think about the null. Think about there not being a relationship there, because if they then go in and see it's not the appendix, they have done an unnecessary surgery, and that is a lawsuit waiting to happen. They have to think about the null. So that's a medical example. In the research world, in the psychological research world, it's just covering your butt, right? Like, it's just covering your bases and making sure that no one can come in and prove you wrong, which that's kind of superficial, but also just making sure that your data is what you say it is, right? And you have the math, you have the statistics to show that it's not the null. The null is wrong. It is actually my independent variable that is causing that relationship, that cause and effect relationship. And that's it. Does that help? I'm so glad it was helpful, Carolina. Yes, totally. Okay, good. Good. All right. Let me make sure that there wasn't anything else I want. Okay, let's do a recap, and then I'm going to get to your questions. Okay. All right. We talked about correlations and experiments, and how experiments are the only research method that allows us to determine cause, and how that cause has to be backed up by statistical significance. Otherwise, there is no cause. It means absolutely nothing. We looked at the normal curve and what that could look like on the test, right? Both in a multiple choice and in an FRQ. And then the null hypothesis, right? Meaning, and I gave you the appendix example for conceptual understanding. Okay, first of all, thank you so much for being here. I see that some of us have to go, which is totally fine. So thank you. And then here's where I want your questions. So ask your questions and vote them up if you want me to answer those. I'm going to stop sharing my screen so that, oh boy, you big me. Okay, that's totally fine. I'm going to answer some questions. All right, so do you think any FRQ, I'm going to assume that that's on important people? Okie dokie. Here's what my students, please, here's my waiver. Absolutely for certain without doubt, no. But I've been teaching this for 10 years. I've looked at lots of different tests. And I'd like to say that, you know, you can take my word for it. I'm going to say that. I'm going to put a stake in the ground and say, you're going to be fine. I really do not think that they are going to put someone's name in an FRQ and expect you to know it without context elsewhere. An example being a name that I've seen in an FRQ is Maslow. And the bullet point was Maslow's hierarchy of needs. They're not asking about Maslow there. They're asking about his hierarchy of needs. Maslow was just a really helpful hint. Like, remember, this is the guy who asked about that. And that's what I tell my students in a multiple choice question. They very much could ask a multiple choice question of who is William James, or which person below did blah, 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 learned helplessness. That would be Martin Seligman. They could ask that in a multiple choice question. In most cases, however, what I tell my students is that the names are kind of like helpful hints. So let's say that in a question, they tell you all about learned helplessness. And they throw in there that Martin Seligman was the guy who did all the research on it. And then they give you A through E and want you to identify that it wasn't social loafing or social facilitation. It was learned helplessness. Martin Seligman's name being in the question is just a little helpful hint for you to feel even more confident about your answer. So do you think any FRQs will be about important people? No, not exclusively. They may have one in there. I really doubt even that though. So I hope that helps. Okay, let's see. Can you send a link of the slides you just taught? I sure can. I'm going to talk to my Fiveable peeps and make sure that I do it correctly. I'm self-studying site. Go you. Okay, so let's see. Can you do sensation and perception as in a totally separate, like, live review session? Is that what you mean? The 17 votes that we got for can you do sensation and perception? Can you give me like a yes or a no? Do you need to know about the eye? Yeah, you need to know about the eye. Yes. Okay, I'll see what I can do. I'm not going to lie. I've got lots going on this week. We got T-ball practice Tuesday night. I'm a mom of 3 that we got a live review session with my students doing on the brain. Oh boy, I think just a review session. Oh boy. Okay, can we do a practice FRQ via live this week? Okay. Woo! Okay, so I'm going to say, can you do sensation perception? I'm going to try. Okay, I will try. I cannot talk about sensation perception in this one though, because oh my word, it's such a big one. Okay, let's see. Will you please go over confirmation bias, overconfidence, heuristic, representative of these terms confuse me. Okay, so going over confirmation bias, overconfidence. Okay, let's talk easiest to most complicated. Overconfidence is exactly that. Right? And that some of you may have totally slacked all year, but you feel great right now. Like, I'm going to do so great on this test. That's overconfidence. And that's it. That's it. So that's overconfidence. Confirmation bias. Okay. Confirmation bias is different from lots of the other biases. And what I tell students is that with confirmation bias, you are looking for information, and that the person who is committing confirmation bias is actively looking. Oh, so Fiveable commented, we would like But Fiveable will be hosting several AP Psych cram sessions this week. So you should totally catch the cram sessions. They're going to be great, right? Like, they'll be totally great. And then I'll definitely have to like pick up some more next year. So it'll be great. Okay. Confirmation bias, you are actively looking for information and only see. It's not that you only look for, although that is it. It is you're only looking for. But oftentimes you only see the information that confirms your pre-existing notion or understanding. Likewise, you then don't see or totally ignore things that disprove you. Okay. All right. So representativeness heuristic. Okay. Here's my big one. Okay. Here's my big one. if you see representativeness heuristic on the FRQ, you had better say the word prototype. You had better write that word in the FRQ, okay? Because representativeness heuristic is just looking at something new and determining if it fits your prototype or not, making judgments based off of your prototype. Okay. All right. Let's see. Let's see. Review ethical principles and concerns. Okay. So review ethical principles and concerns. The big one here, ethics is not that big. So I don't want you to freak about that. The biggest thing you need to know is that you have to get informed consent. And then the other vocab terms that are kind of associated with it, like confidentiality, being anonymous, which is kind of like that confidentiality piece, right? Deception. In that if there's going to be deception, you have to prove that it's absolutely necessary, not just because you want to lie to some people, I guess. And then with animals, you got to treat them better than most people in a lot of cases because you're making sure that they stay alive. You're not just researching them. And then the other one I'll say about ethics is with minors. Meaning underage, right? Under 18 years old, you have to get something called assent, ASSENT, which is continually asking them, are you okay? Are you feeling all right? Do you understand what's going on? Okay, let's see. Flaws with particular research methods. We'll just be on a few more minutes and then I'll say thank you and deuces and it'll be great. Flaws with particular research methods. Okay, so really the biggest flaws with research methods being that none of the other ones can determine cause. And with its purpose comes its exact flaw. So like a case study is just kind of doing preliminary interviews to see if you can do further research. But therein lies its flaw, right? You can't do anything more than just say just that. I just interviewed a few people and this is what I found. So I want to, you can't then generalize, right? And then the flaws with experiments being, and I didn't start that. Sorry, answering. The flaws then with an experiment being it's really huge, it's really expensive, it takes a lot of time. Okay. I would recommend that you, and you'll have to ask your teachers for this, go over the last 2 years at least. So I would recommend that you have at least seen the last 2 years tests, which only your teachers can give you the multiple choice portions. Yeah, that's pretty much it. Let's see, what type of research is longitudinal? Oh, that's a good one. Okay, so what type of research is longitudinal? Like, what are its main points? Okay, so I think you're just asking me what is longitudinal versus cross-sectional. Okay, longitudinal is long, and I don't mean just a year. I mean, okay, so Eliza Harden, wait, so if we need to talk about representative heuristics, we should mention prototypes? Of course, because that's the entire basis of its definition. I encourage you to Google it real fast. That prototypes, you have to say the word prototypes in an FRQ if representativeness heuristics is on it. Okay, back to this question. So what type of research? Longitudinal is long. Think like 20 years long. So twin studies with Buchard, I think Bouchard maybe, his were like 20 plus years. That's longitudinal and it's with the same group. Cross-sectional is shorter. Think like 1 to 5-ish years and is a bunch of different groups. So think like 18 to 25, 25 to 35, 35 to 45-year-olds. And you're researching them over a shorter period of time. Okay, so this is the last question. Oops, sorry, you're probably hearing that. Okay, so this is the last question I'm going to answer. What would you recommend to do in answering FRQs? Coming from a person who tends to overthink tests. First of all, take a deep breath, build your confidence this week, and know, actually change your self-talk, right? Like don't say I overanalyze tests. Say that I do a really good job of reading questions, and that's a huge advantage. I just need to maybe work on taking a deep breath and know that each one of the questions technically very much leads me to its own answer, especially the multiple choice ones. The answer's on the paper. But with the FRQs, you know it. You know it. You can even benefit from what you saw in the multiple choice, okay? So here's what I recommend. I recommend using the question itself as a checklist, making sure that once you've written about it, you check off what you have answered. I recommend that you answer in paragraphs based on each term you are addressing from the FRQ. A lot of times this is per bullet point or per term. It could be either one. And then underline the term. Okay. I also recommend, this is the last thing I'm going to say, is that you answer in order. So that means if you don't know that first one on the test, I want you to skip about this much space or maybe more, right? And start answering the second one as to, because you know that one, right? And it's going to build your confidence and it's going to be great. Okay. All right. So I'm going to wrap it up because I hear my crying baby in the background and it is bedtime. So thank you so much to everybody for coming. My teacher said, if you don't know, gosh, that's crazy. Okay. Well, thank you so much, everybody. I hope that this was helpful. I'm sure that we're going to make these slides available. And hey, everybody, great luck. Wear something comfortable, but not too comfortable because you don't want to be falling asleep. And, you know, get a good breakfast the morning of, good dinner the night before, get some sleep. And remember, Yerkes-Dobson. Right? Yerkes-Dobson. You want to be amped up a little bit, but not too stressed. Find your happy medium, pump yourself up with like some Beyonce or something beforehand, and take a deep breath and know that you're going to do great. And that's all. Everybody have a great night. And now I have to figure out how to end this. Okay. Bye.